Well, hello, everybody. My name is Tony Schufo. I'm the Director of Sales for Control Consultants, and welcome. I'm proud to be here today and be partnered with the Tritium Group. We have a very good panel of experts to talk about the Niagara Data Service offering, as well as a few other surprises that we will be talking about as we go forward. I'm also co-sponsoring this with Temperature Control Systems, Shane Aldridge, and we're looking forward to getting some input and feedback from you as we go through this event. So just to talk a little bit briefly here, the Niagara Data Service is a software service that's built within the Cloud Suite, and it's designed and built upon openness and continues that thought process and that motive. We have a few presenters today. Roxette Mancero Sanchez, she'll be doing a quick introduction of the Niagara Data Services. And then we'll have Kevin Mamajek, who will do a deep dive on and a demo, kind of talk about what the process and the program is capable of doing, and spark some of your interest on the product. And then we do have some special guests today. We're excited to have on board with us the Ellipsa team. They're going to be spending some time discussing how Ellipsa integrates to the Niagara platform seamlessly. And I'm sure you'll find that very interesting and very eye-opening for AI and monitoring as technology's growing and changing. Just a couple of housekeeping items. This is going to be about a 45-minute discussion and demo. If it goes longer than that, that's fine, but that's what we're figuring. During the discussions, if you have any questions, by all means, use the Q&A tab at the bottom of your screen. Our intention is to take those questions and open up additional questions at the end of the demonstration for about 15 minutes. Other than that, I just want to thank you all for taking the time out today to be with us, and I look forward to hearing from you, and also look forward to seeing the demonstration and presentation. So I'm going to hand this over to Roxette, and we'll go from there. Thank you, Roxette.
Cool. Thanks, Tony. Good morning, everybody. This is going to be one of the many webinars we're doing with CCI and TCS this year. We're going to kick it off talking about the first part of the Niagara Cloud Suite, which is going to be the Niagara Data Service. We're going to have Michael Stabile joining us and doing the presentation on that. Kevin Mamajek is going to demo how the Cloud Suite works and what it kind of looks like. And then we're going to have Josh and Jeff with Ellipsa talk about what you can do. So the Niagara Data Service being a tool to utilize that gets us to a third-party app such as the Ellipsa app, which gives us that AI digital twin and kind of infrastructure there for additional, programming and apps. So I will let Michael Stabile take it from here. Thank you guys for joining us today. And like Tony said, if you have any questions, throw them in the chat.
Thank you, Roxette. Hang on here a second. I will stop my video and start sharing. Go. Okay, can everybody see that?
Yes, we can see that.
Okay. All right. So welcome to Gaining Insights from Your Building Data, Niagara Data Service and Ellipsa AI. As we mentioned, we'll be going through this presentation, talk a little bit about what Niagara Data Service is and how we take that data from your Niagara instance to the cloud to a service like Ellipsa, be able to get some valuable insights. What we're going to do is look at the value proposition for various folks. You may be an integrator that's with us as a partner. You might be an end user, or you might be another system or another software provider. Look at the advantages of Niagara Data Service, how we get started. Kevin's going to talk about that, and then of course Jeff and Josh talk about Ellipsa. So the Niagara Data Service is actually the first part of the Niagara Cloud Suite. It's a scalable solution. It's a Tritium cloud that's actually Azure-based, where we host our cloud, that allows for remote building management services in our model of open and extensible integration. Niagara Cloud Suite is, as you see on the left, the first offering. The Niagara Data Service is the first offering of Niagara Cloud Suite. Coming soon will be Recover, and then later this year, Remote and other future offerings. So stay tuned, as Roxette mentioned, with multiple webinars coming. We'll probably have one on each of these as we go. Today with the Niagara Data Service, we're talking about taking contextualized modeling, taking the data from your Niagara instance and your histories, and being able to provide that out for third-party application access in a secure fashion. So this is Niagara Cloud Suite. I want to make very clear. It is not really something we want to consider as a product in itself. It's an enabling technology that's permitting you to take that fully contextualized data. So, we can already export data from Niagara. I can send out information, but having all of the metadata behind it, all of the tagging that goes with it, is very important and a unique feature of Niagara Data Service. And we do that through a secure means to get that to the third-party apps through a cloud API. So what does that do? Well, if you're a building owner, as an example, you might have seen cloud apps that are out there that you like. In fact, the bottom left, you'll see a screenshot from Ellipsa for energy management, digital twins, and predictive maintenance that we'll be talking about today. But maybe you aren't really sure how to connect. And we've worked with Ellipsa for a couple of years on our JSON toolkit and MQTT, various ways to get data out of Niagara. But they can talk about how much easier Niagara Data Service has made that for them. Also, you might be able to might want to develop your own dashboards or have one of your integration partners build them for you. And that's what Niagara Data Service can enable. As you can see here, just right on the management plane of Niagara Data Service, there are some basic visualization tools. So here, just doing a comparison between room and outdoor temperatures with some visualization capability. You might also want to get rid of the gateways that might be an IT issue for you. And finally, and most importantly, you as a business owner or building owner, facility manager, want to own and control your data. So this data belongs to you, and you control the access to it through API keys. It is a single data model that you can use to serve multiple cloud applications. And it's managed and it's a secure repository for your historical data as well. So it can offload a lot of the data from your JASes and supervisors and make them much more performance oriented. For our integration partners, why would you use Niagara Data Service? Well, what we saw before is you might have clients who want to leverage those cloud solutions. You need to do it quickly. And I think you'll see with Kevin today, it really takes just a few clicks to get up and running. Or you need the flexibility to offer a service to your customers, no matter their size. So based on your capacity, you can divide that up between your clients and offer them various services, managed services from your instance. Additionally, you might like to enhance the cloud offering you already have. So Niagara Data Service can bring in that contextualized data that you may not have been able to get before to enhance what you are offering for your customers today, saving you time and money. Finally, you want a channel-friendly business model. Niagara Data Service is just like all other Niagara products available through your distribution chain. You control relationships with your customers. You do all the performance enhancements. Really, Niagara Data Service is a tool set for you to use to help customers manage their environments much more easily and help you provide more offerings. And if you're a cloud solution provider like Ellipsa, why would you consider Niagara Data Service? Well, it immediately expands your market. So you now have access to take your application to a very broad Niagara customer base. You don't have to do any programming. As you'll see with the simple API access, it's much easier than building out packets and transmitting those. There are no site security or IT headaches. We're going to handle all of the certificate management and security behind the scenes with Niagara. So therefore, it's a much faster time to value for your solution. So what are those Niagara Data Service advantages? Probably the most important one here that I want to highlight is the contextualized data. So in the orange box, you can see in this example, just the number 72. And if we say 72, what does that mean? And that's the data that we could have sent out previously, but we didn't really know what it meant, what it was tagged to, what it stood for. In this case, this is a rooftop unit number 1. It's in degrees. It's a unit in degrees. It's in Fahrenheit. It's located in Richmond, Virginia. It correlates to the outside air temperatures, and it's at building 51, which actually is our headquarters in Richmond. So you see that there are a lot more information you get than just sending out the number, a lot that goes behind it. Most applications really have to start by pulling all that together for you. Niagara Service brings that, Data Service brings that up automatically. With that, I'd like to introduce Kevin Mamachek to talk about how we get there.
Man, that was quick.
Hey, I'm leaving you time for demos, guys.
I'll tell you what. All right, hold on, let me get my Zoom.
All the important stuff.
That is it. All right, so what I'm going to do is I'm going to walk you through the part that's on Niagara. Actually, let me turn my camera. All right, so I'm going to walk you through the part that's in Niagara. When you talk about what we've done, we've kind of watched a lot of integrators and customers that were trying to put their data in the cloud, overcome great obstacles, and then they find that once they got over those obstacles, it wasn't very easy engineered or duplicated, right? So what we did is we kind of stepped back and said, okay, how do we get Niagara data into a common place so that the customer can give access to that data through a very common method to allow third parties to run the gambit of machine learning and analytics and statistics, and to be able to take large portfolios and put all that data into one place. So that's easier said than done. And so what you'll see is that we in the Niagara Cloud Suite have kind of looked at the individual pieces that we have to have, which is one is plumbing. We have to have an architecture that makes it very easy for a Niagara person to be able to send Niagara histories to the cloud. And this has to be super simple. And when you see no programming required, I laughed, right? Everybody's using Chat GPT to code now. No, there's not coding, but I will show you the way that if I would do this without Niagara Data Services, that's the engineering, that's the coding. So go ahead and finish out the build. So Niagara Cloud Suite is a suite of applications or functionalities of the cloud that we will have. Niagara Data Service is just one of those features. And so this will either run on a supervisor or run on a Jace, and it does all of the heavy lifting of how you would connect a supervisor or a Jace to a backend cloud, right, to our public cloud. And if you've done any type of cloud work and you tried to connect to a cloud, you had to deal with certificates and you had to have unique device certificates. And then the cloud wants to make sure that it has a private connection between that device. And it got to be kind of difficult if you were trying to do this for your first time, or even if you were doing it over and over, you still had to deal with this mess of certificates to make sure those are in place. And there's a lot of trial and error, there's a lot of complexity. So how can, when Tritium looked at it, how can we remove that complexity of setting up that initial connection to that cloud? Okay, so part of that is that we, go back one, is that we've created a service that will do a lot of this stuff for you on that JSON, on that supervisor, okay? Only requirements that you have for the versions of Niagara is that it's the long-term support release, which at the current is 4.10, and the latest feature release. So those are the two pieces of the puzzle, and you have to have an SMA. And why you want the SMA is as we build out these new services, we are actually doing some plumbing work within Niagara to enhance that. So you'll always want to get on that current supported release or the feature release to be able to take advantage of those. So having a software maintenance agreement gets you carte blanche. You can upgrade those pieces of equipment to that version. So go ahead to the next slide. So I'm just going to cover how we get the stuff to that cloud, right? And then Ellipsa is going to actually show and demonstrate how they get the data from the cloud to their application, right? And so that's the magic piece to this puzzle, right? So the hard plumbing part, which is kind of boring, and I have to do a demo on it, but you'll see that it's not so bad, especially if you've done cloud connections yourselves. This is going to be a moment where you're like, okay, aha. So this thing. There's a service I'm going to show you that runs on Niagara, and then it talks to this backend cloud IoT gateway that connects and takes all this streamed data. Well, actually, it takes every if you have a 15-minute history, right, it's going to take every 15 minutes and get that history updated. And then it's going to put it in a common place that then a set of APIs, which are common, and it's only one set of APIs, are available for third parties to access. And I'm not going to show that. We'll just talk through it. But the demo will be how the Ellipsa application pulls that data from this common place. And for Ellipsa, they just have to write one API, and then they can set it up to bring in all kinds of different components through Niagara, such as a different building, such as a different JSON or supervisor. All right, so with that, I'm going to share my screen. All right, and I'm going to share this screen. All right, so does everybody see my workbench?
Yes.
All right, so we're good. All right, so what I'm going to do is kind of show the workflow. It is to actually connect a JSON or a supervisor to the cloud, to our private cloud or to our public cloud. Okay, so what I want to show you is there's 3 types of components, and I can walk you through this. And I've already got it set up. It's kind of like the cooking show, right? I've got the ingredients, and then I've baked it, and so you don't have to watch the process of the actual onboarding. So what I'm going to do is walk you through the steps that I had to take in order to get this JSON, which is in my office, which is on a private network, right? A secure network that is very difficult to get ports changed, right? So IT has this thing locked down. And so I've got that set up. And what I'm going to do is when I add the service into my station, my services on my station, right? You'll see that I've already added it, and we're looking at it right here. So I just drop that in there. And on the first time that it's dropped in, it's saying, okay, this is a brand new installation. Or it's not a new installation of Niagara, it's the first time I've been loaded, and we're going to start to set it up so that I can actually transmit that data to the cloud. And you'll see that there's a couple folders that are usually empty. What you'll see is that channels will be empty, transports will be empty, and there'll be this authenticator. And essentially what I do is I go over here and I click on that and I say start registration. Now I'm not going to do that because I've already done it. So what I want to show you is just with that one click, it's going to do some very heavy lifting, and it's going to go and it's going to talk to the back end in the cloud and say, okay, here is a new JSON, and I'm going to do some stuff and give you some information about that JSON, like the system ID, and we're going to authenticate, and it's going to create a URL, which is right now empty, that I will click and I will authenticate that I want this to go to this particular customer space. And so in the cloud, there's these, what we call silos. Every customer gets their own silo so that their data stays inside that silo. And so that heavy lifting starts out and says, okay, we're going to communicate. It gets a device certificate that only my device and the cloud connection understands, right? It's encrypted, and it's only the 2 entities, the device and the cloud, can actually unencrypt that. So it's very private, and it's done across HTTPS. And why that's important is that that is a common protocol that we can get a outbound connection to in a very secure environment. And as it goes through that process, I go to that URL, I type in my credentials, and then it automatically creates everything else. So I initiate this process. It takes device certificates, which, by the way, are replaced every so many months. We roll those because that's part of the security process. And I don't have to worry about any of that. I didn't have to worry about signing a cert. They're all from that back end, automatically created and installed and configured within the service automatically. I can't stress that. And so part of what you'll see is once it's authenticated, I get certain information, like I have a system ID that people are going to need to know. I know what my, that this is essentially a JACE with the Titan code name, and there's the license, and it's going to a cloud integrator called Niagara Smart Buildings, and it's registered and it's been authenticated, and everything is good. In fact, if you double click on this, do I have one there? I'll double click on it. You actually see that you're presented with all the check marks, right? Green check mark, you're good, you're linked. Here's your system ID. So this is going to be important to understand that you might want this number to hand, like I handed that to Ellipsa and said, hey, here's the JACE, go do some magic, right? And so that's where I get that number. So when you look at, oops, go back to this. So when you look at that, I've already done this heavy lifting of creating all those certificates and all that back-end encryption. And it's doing a lot of stuff to say, okay, I'm going to set up some transports, and it automatically configures these transports. So if I was going to do this by hand, I would have to then take those certificates and integrate them into the transport. And then we have a queuing protocol that allows us to build up a queue so that if the cloud connection goes down, we store those and then forward them when the cloud comes back up. So I don't have to worry about any of this, right? And then it starts to create these channels. And this is one of these things where these are the channels that we have at launch. There'll be more. And so the messaging and heartbeat, I really don't need to worry about. Those are things that the back end and the Niagara need to keep communication to be able to do some of these things. The next one is this model that I, as the integrator, want to initiate really once, or anytime I change the JACE. And so all I would do is come down here and I would go ahead and execute the modeler. What this does is it looks at the JACE or the supervisor in its entirety, and it collects a working model of what that is designed as, right? So it's not taking the data, it's just looking at how it's configured. What devices are there? What protocols are being used? What points are there? What are their names? What are the associated tags associated with that, right? It's doing a complete model of this, and then it's sending it to the cloud. And then the cloud grabs a hold of that model and goes, okay, I understand what you have. I'm now going to build out your data lake, as they call it. It's essentially a time series database that we're going to start putting data into. And it does all of that prep. So as that model is up there cooking, because it usually takes about 15 minutes on when the cycle is, I, as the integrator, would come in here and say, all right, let's take a look at this history component of the service, right? And why this is important is that essentially, when I first connect to Niagara, right, or I'm first connecting this to the cloud, I don't want to send everything, or maybe I do want to send everything. In my case, I'm sending everything, right? But some of our customers like, well, I only want this data to be up there. And so what we do is we allow you to choose what you want to send from those histories up to the cloud. And again, for some of our customers, they might have 10 years of data. They're going to look at it and say, well, I don't need X of the data. I just need these 3 things to start out with. Later on, I might add them, but for right now, I just want to do those 3 things. Okay. So I pick and choose, or I just, in my case, I just turned on the auto, and it just takes all my histories, and then we'll send them to the cloud. And we do it in a very smart way in that we will take all of that, we will compress it as a data set and send one file. We're not streaming all that data to overload anything. We do it all in one thing, and then the back end grabs that, says, okay, I'm going to uncompress it, and then build out that database. The other cool thing that we do is, if you look at our history service, right, we introduced an ability called an archive history provider into Niagara a couple versions ago. We actually will configure this archive history provider so that you could say that on this supervisor or this JACE, I only want to have 6 months worth of data. The rest of it, I want it to be in the cloud as an archive. This archive history provider will go get it if anybody asks for it in Niagara. So you can kind of take baby steps. You could have some of your data in the cloud. I could have all the data in the cloud. I could have maybe a year, all of my archive stuff, and I keep a year on my soup. It's your choice. And what that allows us to do, especially for people with large databases of history, 5, 10 years on a soup, that's a big server. That's a heavy lifting server. This could offload a lot of that requirement to store all of that long history in the cloud. And then when something in Niagara, like Niagara Analytics or what have you, or a graph inside of a building, somebody pulls it up and says, I need to know what this looked like last year, it will go get it. And they have no idea that it just pulled it from the archive. So it's very, very powerful in that aspect. And so that's the steps that I had to do to enable that connection to begin putting that history into the cloud. Okay. I don't have to do any JSON packets, right? I can do this now with the JSON toolkit. This is the coding or the programming that Michael was talking about. This is the longhand. This required me to know how to configure all of those components. It required me to understand what points were there, and I'd have to go create these connections. I would have to go configure the HTTP client and tell it what data I'm going to transmit to it. I'd have to also do that to get it back, right? So these are the things that we've made or simplified, in that it's now easier to do this and scale it than it would be if I had to do all of this remote engineering within the toolkit. And so these are actually examples that we did last year with Ellipsa on getting Niagara data into their cloud, right? Into a version of the data that they needed to be able to extract. So what we've done then with Niagara Cloud Suite is we've simplified it so now that Ellipsa won't have to go in and do any of that engineering inside the Niagara network. They'll just go to an external API and be able to get that same type of data, all that contextual data with tags, and be able to then add value to that data. And they are issued an API key and a secret. So that is something that expires. You would reissue that as the SI for that customer so that they can control access to that data. And with that, I will turn it over.
All right, thanks, Kevin.
Jeff, I do believe, who will show you the magic of taking data, which I just showed you the connection on what it looks like on his end when he calls that common API.
Sure, 1 second here. Okay, thanks, Kevin.
Yep.
Okay, can you guys see my screen okay?
Yep.
All right. Thank you, everyone, for having us. So my name is Jeff Kimmel. I'm the co-founder and CEO of Ellipsa. As Kevin mentioned, so our goal is to simplify the ability to add machine learning to smart buildings and effectively to make them more intelligent. Kevin walked through the different ways you could do that directly in Workbench. But as he mentioned, it requires creating JSON strings, sending it via HTTP, doing something with the return, etc. So our integration with Niagara Data Service drastically simplifies that. By really what we're doing is creating those the API calls to integrate into getting data from Niagara Data Service and making it a point-and-click solution within our platform. So from a configuration standpoint, the API key and secret that Kevin mentioned is already kind of stored in our system. And once that's stored, we have the ability to add customer IDs and then the system GUIDs. And so from an end user perspective of a single building, perhaps you would just have one customer ID. But if you're a system integrator looking to offer kind of machine learning as a service to a variety of customers, or to manage multiple customers under one, you have the ability to add multiple customer IDs here. You can see we're connected to Kevin's instance at Tritium and Steven's instance at Tritium as well. And then once you are focused on a customer ID, you can add a series of different system GUIDs. So whether that's multiple JASes, multiple supervisors, et cetera, you could put them all under one view of the system. So now with that said, Ellipsa is a machine learning platform to generate models for buildings. So if I focus on this customer ID and this system grid here, you'll see a series of panels in our system. And these are the devices or equipment that I'll show you kind of how we're pulling that from Niagara. But the three areas that I'll focus on and kind of showing what we do in terms of adding value to the end user is predictive maintenance or fault detection. As you can see here, this VAV has a series of dots. One is green, showing that the damper predictive maintenance is okay. We also have one for a heat exchanger on the VAV. So if I click on that, I'll show you kind of walking through the dashboards and then show you how simple it is to kind of pull data in, add new equipment and devices. So here you can see we are monitoring with the predictive maintenance for this damper. Once it's set up, we're polling the Niagara Data Service every 15 minutes, and we're pulling back the current values. And then we are also taking those current values and making a prediction against an AI model. And that AI model, as I'll show you later how to build, is learning what normal operation is of a particular machine, and even in this case, a particular component of a machine, to be able to monitor for abnormalities of any kind, that the result being a prediction of a machine starting to trend away from normal, or an issue that can be alerted to, say, a maintenance team that's indicative of a problem before the problem actually occurs. And so on the dashboard, you can see here a series of things. So we're monitoring the current prediction is everything's okay. The health of the system is okay. If the system was predicting an issue, it would show in red, and it would show a confidence score in terms of how confident is the AI in this actually being an issue. And then further down here, you can see historical data for this particular historical predictions and confidence. You can see over this period, everything is actually okay. The other thing to note is, although all of this is pulled in through Niagara Data Service into our system, you could still utilize MQTT or HTTP to pull these insights back into Workbench. So that still provide kind of that single pane of glass, utilize data, Niagara Analytics, et cetera. The other piece, the second piece I should say, is the statistical analysis. So you can see here, it says retrieving data from NDS. So once it's configured of what points you want to look at, we are utilizing those kind of pre-configured, say, APIs to Niagara Data Service to pull back the current data for that period that we defined. And the period initially is 1 week. And then what we're showing is the different data points that we are looking at and showing cross correlations. So you could see, okay, as the damper position goes up, there's not a strong connection to the temperature going up. The room temperature actually goes down, supply temperature is going down. So it shows you how your data points move with each other. You'll also notice up here, we have the reheater status didn't have enough data for that period. It's not reporting the history as frequently, so it's actually excluded from the dashboard. But then down at the bottom, we'll have a variety of different charts to show, okay, how is this certain data point, say room temperature, how is it trending? So over the last week, here's the trend, here are the averages, min, max, mean. What are my averages by day for this data point, by hour of the day? And then how about the outliers of that particular data point based on day of the week and hour of the day? So based on this here, at 1 o'clock on April 1st, the temperature was higher than typically what the system has learned and seen for that particular day and hour. So that could be set up as an alert, or could just be a view for someone to kind of look through and just better understand how their systems are operating. And then the third piece is the scenario analysis. So we have a second VAV here where we've created a machine learning algorithm that's really just looking to predict the room temperature based on the supply temp from the AHU and the damper position. And if you run the scenario, in this case here, we could throttle different, say different temperatures to understand based on these scenarios, what will the room temperature be? Or another example, this with the flexibility of our system, it's basically whatever data you have to predict, you can build a machine learning algorithm for. So you could theoretically, which I'll show you in another example, is predict, okay, based on the weather, tomorrow, what is my power consumption of a chiller going to be? Or what will the occupancy of a room prediction be based on a time of day and day of week? So a number of different use cases that you could build in our system and then utilize this digital twin kind of scenario to throttle and create different scenarios. So with that said, the value of the NDS is in creating these models quickly and connecting to the data. So there's two different ways to do it. There's templates that we've created and adding a custom, which is not templated. So I'm actually going to start with adding the custom to kind of show you what's involved. So I'm going to look at an AHU from the system. For grouping purposes, you could define what type of machine it is. And then you could say, okay, I'm going to create a statistical analysis, predictive maintenance, or scenario analyzer. So if I click on scenario analyzer, you'll see these fields right here. That was instantaneously through the APIs. We've called an API to say, for this customer ID and this system GUID, return to me all the points in Niagara Data Service that have a history that start with the tag name AHU. For the device or the folder. The next iteration of our service will utilize tagging more to be able to find tags to automatically detect points, etc. But for now, the version here I'll show you is being able to pull in based on your device names and your tag names. So I'm going to look at the static pressure and supply temperature and move them over here as the predictors to predict. Again, you could choose anything you want to predict in terms of data that you have, a column you have data for. So I want to predict the power or the kilowatts on this AHU using the supply temp and the static pressure. But I also want to utilize outside air temperature. So for that, I know that in my Niagara system, I have that as outside air OA temp. So if I pull these three in and click save, what this is doing now is taking those 4 data points where it's learning and saying, okay, I'm going to take the cloud ID, which is associated with these data points, pull in all the history to then automatically build a machine learning model to predict the kilowatts based on the temperatures and the pressure. And you could see here, as it's going now, we run through 23 different machine learning algorithms to find the one that best fits your data. So the one that's most accurate in terms of predicting. And that could be a different algorithm altogether for, even if you're trying to predict the power of a, say, an AHU, if you have 2 AHUs, that could be 2 completely different machine learning models. So now, similar to what I showed on the last page with the room temperature, in this case here, we could throttle different things and predict what the power is. You'll notice it's negative. That's actually, with it being kind of simulated test data, there are negative values in the actual data. So it might look to be off, but it's actually accurate in terms of its prediction based on the data it's had. But here you could say, okay, if we bring down the supply temp, if we bring, say, if outside air drastically drops, creating a variety of different scenarios to produce what will my power consumption be. And then separately, we could build a different model, again, purely based off of, say, the outside air temp. And now with that, we could feed it, say, the 10-day forecast to determine, okay, what will my power consumption be of this piece of equipment, say an AHU, chiller, boiler, or the building as a whole, to start to simulate and understand how your, not just how your buildings are, and equipment is operating in current time, but starting to create scenarios to understand how your building will operate under different circumstances. So now with that said, showing you how to do that, it's simple point and click, but there's actually, a lot of instances where it could be easier, and the easier is through templates. And so I'll show you, for example, on a water-cooled chiller, similar to the searching for points here, on our side, in the middle, we have a variety of different data points that we need in order to create these machine learning models on the right. So we could automatically, if you map your data points and you have enough data points, you could create a chiller energy consumption model, a power based on weather model, individually monitor the expansion valve, an evaporator, compressor, condenser, etc. So that way there, you're simply connecting your data for, say, this chiller, and it automatically then goes through and creates all the models that are applicable to that device. And so now with the point and click, you're not just building 5 models individually, you push one button and it automatically will create those. In this case here, for this Jace, we don't have a chiller, but I'll walk through doing so with another VAV. So similar with how I showed in creating the AHU model, if I type in VAV, you'll see here all the different VAVs that are connected that have histories for this particular system GUID. So if I want to build a model for VAV3, that'll filter it down to just that, say VAV3. So now if I have effective the set point, say the damper position, and the room temperature, you'll notice here now, I don't have enough data points to build the VAV energy consumption model. I have enough to build the damper predictive maintenance. It would be stronger if I added the supply temperature, and I don't have enough for the heating in this particular case based on what I've put in. But let's say I want to add supply temperature. I know that's coming from my AHU. So if I search for that, it goes through, pulls the data points. Now, if I connect this here and create the model, it's going through now automatically, again, pulling the data points from Niagara Data Service, building the models that it has enough data to build. And in this case, it's the damper predictive maintenance. If I come back here now, you'll see VAV3. I have the damper predictive maintenance, and it shows differently from what I showed you on the other VAV, because now it's in learning phase, as in the model's been built, but it's waiting and ready to stream live data. So now it automatically been queued in our system and scheduled so that every 15 minutes it goes out and pulls back the latest data point for this, runs a prediction, and then can alert people, as I mentioned, of indications of problems. So the Niagara Data Service really allows us to connect to the data in a much more seamless way, and allows the users to build out a series of fault detection, digital twins, etc., which without having to write any code, even if the code is simply just JSON strings and HTTP configuration within the workbench. So I'll stop there and hand it back, and then we'll go over questions as they come.
Okay, thank you. Appreciate everybody's time. As we mentioned, I think Shane, you wanted to close us out on this. By all means, go right ahead.
Yeah, no problem. I just wanted to, take a second to thank everybody. Thank our partners over at Tritium for always, leading and pushing the industry. Always keeping us up to date, webinars, technology. So thank them for the time today. It was a great presentation. Also like to thank Jeff from Ellipsa. That was eye-opening, good presentation, easy to put together. So I appreciate that. And then from CCI and TCS, everybody that joined, our customers, thank you for your business, and thank you for the time today. And just want to say thanks to everybody for attending. If you have any questions, for Tony, myself, Michael, anybody else, just reach out. We're here for you. And thanks again for everybody's time.
Okay, we'll give it a few minutes here, and if there aren't any more questions, we'll sign off. But we'll hang in here for a few minutes just to see if there's anything of any interest. And like Shane said, thanks very much. We're going to be doing quite a few of these, and they always seem to spark up interest and bring opportunities. We're available to have any type of discussion development with you and your teams. don't hesitate to reach out to us. I would ask one thing. I always say this at every one of these, at the end of every one of these webinars. Um, on our social media, we have a bunch of different locations to access and be part of the team, the CCI, TCS, and the Tritium team. I ask that you either select a follow, if you will, either through LinkedIn, Facebook, or Twitter. As part of being part of our family. You'll get all the updates, all the information, next trainings and things like that. I'd like to say I get $1 for every time I ask somebody to join one of these social medias, but I don't. It's a really good service that the Kelly team developed along with our clients and our customers. So just consider doing that. This way we're able to provide you with additional information as things go forward. So. Any questions? Oh, we do have a question. Will, do you want to handle that? Roxette?
Oh, yep. I think
Yeah.
Kevin was working on answering this one for Arash because he was asking about running a supervisor on the cloud. And now we've got another one that came in from Perry. So this is an Ellipsa question. Is Ellipsa AI calculating the data, which is inside the cloud only, or direct using the data from Niagara on-prem? Let's answer this one live if you guys want to take it.
Yeah, so at the moment, our system is entirely cloud-based. So if it's connected either to Niagara Data Service or even if it's connected to Workbench, it's sending the data to our cloud. But with that said, we are working on an on-prem version. The predictive maintenance already has an on-prem version, but as a full suite, we will be working towards being able to do it on-prem.
Yeah, I can address the question. So there's a question out there on, is Niagara Data Services or Niagara Cloud Suite a supervisor in the cloud? And I want to say that it's not. So at the present time, we take your histories and archive them in the cloud. What happens is we will build out other services. So we're looking at how customers want to have a complete supervisor in the cloud, and we're looking at it, okay, what components do we need to have in the cloud? Because you can do we were doing containerization, right? That will allow you to run the soup in a cloud environment, right? So you can go that way. But in this solution, we're looking at what are the components that we need to be able to offer connectivity to that data to your providers that you choose, right? And so the first step is to get the histories up there. The second step is you've already asked for, okay, I need to have alarm histories, right? Or can we have schedule histories so that we can understand in a programmatic form what's going on? So we'll add that functionality. There is another puzzle piece that's coming that's called remote. And that is the ability to use this connection that we have to the cloud to actually do remote engineering. So as an integrator, this will be huge for me, because if somebody says, hey, I need you to take a look at the behavior of this JACE and it's connected, right, through this service, I will be able to connect through the portal to that JACE without having to have IT open or a special laptop or what have you. It will actually use that secure connection to allow me to actually get onto that supervisor or that JACE and get to a wire sheet if I need to do some engineering, or add another backnet device remotely without being physically in the building, or add more points. So that's another piece to the puzzle that will be coming in the future. And then the other component where we see a major pain point is backup and restore. We already have a cloud backup, but it's very limited. And so what we're hearing for customers is that, I want to have multiple copies of my backups, and then I have a baseline that I can fall back on. And then I want you to be able to update via the cloud, right? How come I can't push a button and have certain things happening. Well, that's a huge architectural change that we are actually making. And so we will have the ability in the future with that future piece to be able to use this portal to graph your data, give out that API to third parties so that they can run machine learning and analytics. We'll have the ability to back up your architecture and restore components in the future. And then we'll have the ability to actually let you remote in or use remote viewing. If I've got all these local PX pages on the supervisor and somebody wants to get to it on their mobile device, that was always a heavy lift to get that to happen. This solution, when that component comes out, will actually make that a much easier task. That was a roundabout way of saying little pieces are being put together, right? But if you want to run a traditional Niagara supervisor in the cloud, we have something coming out in the fall called containers, or in the summer containerization. That might be something you need to explore.
Thanks, Jeff. That's pretty good. So at this point, if there's no more questions or any other items of interest, we want to thank you for your time today. Please be aware that this is just one of the many that we will be having with throughout the year, and we'll be notified as they come available. Again, thank you very much for your time.
And Tony, I also want to add that this webinar is recorded, and everybody on the webinar will get a copy of it so they can watch it on demand or send it to anyone from their team that wasn't able to make it to the webinar.
That's perfect. Yeah. Thanks again. Well, again, thanks again to the, to the social media team and to the marketing team that puts this together with the Niagara team. So much appreciated. So if there's anything else, Mike, you have anything you want to say?
No, thank you, everybody, for attending. We appreciate there's going to be a lot more of these, so keep your eye open for the more of this. We're all on the cutting edge of technology, and it's important that we offer these types of programs and services to our customers because they definitely are asking for them and need them. There's going to be a lot of things coming out from code perspective and pushed governmentally on learning what's happening inside of buildings to control our energy and decarbonization. So this hits the spot. Great stuff. Niagara's always at the forefront. Tritium's at the forefront, and we appreciate Ellipsa for jumping on today as well. Everybody have a great day.